Hey there! Thank you for joining me. I am Rajendra Bade, and in this video we are going to study how to find a resultant of a concurrent system of forces in a plane. Now you must be knowing that if lines of all forces are in one single plane, then that is coplanar system of forces. Coplanar system of forces we study under three heads: a concurrent system of forces, a parallel system of forces, and a general system of forces. Today, in this video, we are going to focus on a concurrent system of forces. Okay, let's try to know what exactly a concurrent system of forces is. A system of forces in which lines of all forces meet at one single point, that is a concurrent system of forces. For example, here on rod AB, there are three forces acting. All the three forces are acting at its end A. So we say that a concurrent system of forces is acting on rod AB. Most important thing, if all forces acting at one single point, then it is just an example of a concurrent system of forces and not definition of concurrent system of forces. What I mean to say, let's try to understand. Watch this diagram. In this diagram, on rod AB, there are three forces acting at three different points. Is it a concurrent system? Let's check it. If you extend the lines of all these three forces, and if lines of all the three forces meet or pass through one single point, then it is a concurrent system. So here, lines of all the three forces pass through point Q. So this is also an example of a concurrent system of forces. A system of forces in which lines of all forces meet at one single point is a concurrent system of forces. And the point where all forces meet is concurrence. In that first diagram, point A is concurrence, and in the other diagram, it is point Q is the concurrence. Resultant of a concurrent system of forces in a plane. Now here is a concurrent system of forces. All these four forces are acting at point Q. What do you mean by resultant of a system of forces? Listen, resultant means simplest equivalent system. What is equivalent system? Listen, I have made a separate video about what you should know before you start studying engineering mechanics. Go through that video. Link for the video is given below in the description. Also, before you start studying concurrent system of forces in a plane, you must know how to resolve forces along x-axis and along y-axis. I have made a separate video for that. Link is below the description. Go through that video. Remember, you cannot study mechanics randomly. Before you start studying certain topic, there are prerequisites. So I strongly recommend to watch those two videos first and then you proceed with this video. Okay, but of course, you know, if you don't have any problem with resolution of force along x-axis and y-axis, you should proceed. Here, these are the four forces acting at point Q. Now, when you want to know resultant, what you should do? You should replace these four forces by a single force. So, resultant of a concurrent system of forces is a single force acting at the same point where all forces meet. So, all forces are acting at point Q means resultant is acting at point Q. So, remember this. Three parameters are associated with a force. So what about point of application of resultant? It is the same point where all forces meet. So in resultant of a concurrent system of forces, point of application of the resultant is always known. So now how to find magnitude of the resultant force and angle theta, direction of the resultant force? Try to understand. To find the resultant of a concurrent system of forces in a plane, we use following two equations. Rx is equal to sigma Fx. all horizontal forces on the left hand side equal to all horizontal forces on the right side. That is the first equation. And Ry is equal to sigma Fy. All vertical forces on the right side equal to all vertical forces on the left side. So these two equations will give you magnitude and direction of resultant force. Now how to get that? Listen, if you add x components of all forces, you get x component of resultant, Rx. If you add all vertical components in the system, you get vertical component of the resultant. And by law of parallelogram of forces, if you complete the parallelogram, eventually it will be a rectangle. The resultant R is along the diagonal, passing through the point where Rx and Ry meet. Remember, in a parallelogram of forces, length of sides of parallelogram are directly proportional to magnitude of corresponding forces. So height of this parallelogram is proportional to Ry and length of this parallelogram is proportional to Rx. Let theta be the angle made by resultant force with x-axis. Now by geometry of right angled triangle, we can say that R is equal to root Rx squared plus Ry squared and theta equal to tan inverse Ry by Rx. So this is how we find magnitude R of the resultant force and angle made by the resultant force with the horizontal. Remember, theta is angle made by the direction of resultant with Rx or x-axis. Because the statement here we have mentioned theta is equal to tan inverse Ry by Rx, opposite side by adjacent side, that is tan. So when theta is angle with Rx, opposite side will be Ry. So using this expression, when you find theta, it is always angle made by the resultant with x-axis. So what we have studied up till now, a resultant of a concurrent system passes through the point where all forces meet. Then how to find magnitude and direction? Use the two equations. Rx is equal to sigma Fx and Ry is equal to sigma Fy. Using these two equations, how will you find R and theta? Simple. R is equal to root Rx squared plus Ry squared and theta equal to tan inverse Ry by Rx. Remember, when you write theta as tan inverse Ry by Rx, theta is angle made by the resultant force with x-axis. Remember. Okay. Find resultant of a concurrent system of forces in a plane. A simple problem. Here is the concurrent system. All forces are at point Q. It means resultant is also at point Q. So point of application of resultant is already known to you. So to find resultant means what you are going to find? R, that is magnitude of the resultant force, and theta, that is angle made by resultant force with the x-axis. Now, to solve problem, you will have to find first space diagram. What do you mean by space diagram? A diagram, listen, a diagram showing magnitude of all forces in the system, angle made by all forces with the system with either x-axis or with y-axis, and point of application of all forces. So diagram you are watching is a space diagram. So you want to find a resultant of the system of forces, and up to final step what is to be done, you know. Add x component of all forces, you get x component of resultant, nothing but Rx equal to sigma Fx. And add all y component of forces and you get y component of the resultant force, Ry equal to sigma Fy. Rx is equal to sigma Fx. Therefore Rx is equal to, now we are going to add all forces. Remember, if you are using angle of a force with x-axis, then its x component is cos of that angle. And if you are using angle of a force with y-axis, then x component of that force you are going to write sine of that angle. Okay? That is one thing. Second thing, focus on the arrowhead. When you are writing x component, just check what is horizontal direction of this force. This direction is rightwards, upwards simultaneously. That means its horizontal direction is rightwards. That is why its horizontal component is positive 100 sine 65. Why it's positive? Because it is rightwards. When you move in this direction, are you moving on the right side of the screen? Yes. So this 100 Newton force is rightwards. Just focus on the horizontal direction. We know that this force is also upwards. But while writing x component, just focus on the horizontal directions. Angle of 100 Newton force with y-axis we are using in this diagram. So if you are using angle of a force with y-axis, then you should write x component sine of that force. Now 250 Newton force, it is neither rightwards nor leftwards, means it has no x component. Then 20 Newton force. 20 Newton force is leftwards, means minus. 150 Newton force is rightwards. Remember, we should focus on the arrowhead. When you move in this direction, of course you are moving downwards, but at the same time you are moving closer to the right side of the screen. What do you mean by that? This force is rightwards and downwards, but while writing x component, we should focus on its horizontal direction and it is rightwards. So we are using its angle with x axis. So x component is cos 80. So it is rightwards, that's why positive. Angle is with x axis. So it is 150 cos 80. Now just complete the calculations. Rx is equal to 96.68 Newton. You got positive answer. What do you mean by positive answer? X component positive means it is rightwards. Now the second equation, Ry is equal to sigma Fy. You are writing sum of all vertical components. So focus on vertical direction. Just check whether force is upwards or downwards. So 100 Newton force is upwards and we are using angle with y-axis. So here y component is cos component and it is upwards, that's why positive. 250 Newton force, the force itself is along y-axis and it is upwards, so positive 250. 20 Newton force is neither upwards nor downwards, so it has no vertical component. And 150 Newton force is downwards, that's why it's negative, and you are using angle with x-axis and you are writing here y component, so it should be sine of that angle. And this is how you got Ry is equal to 144.54 Newton. Actually, my suggestion is take a pause, complete the calculations and then proceed. So its positive answer means upwards. Now r is equal to root rx squared plus ry squared and theta is equal to tan inverse ry by rx. Use these two formulae and you will get r 173.89 and theta 56.22 degrees. Now one more thing. My suggestion is when you use this formula, theta is equal to tan inverse ry by rx, use only magnitude of ry and rx. So in this formula, use only magnitude of Rx and Ry. So you will get magnitude of the resultant force and you will get that angle theta. Now to identify the correct direction of resultant, check the direction of x component and direction of y component and combine these two directions. So x component is rightwards, y component is upwards. So combining these two directions, you get direction rightwards upwards. Rightwards upwards. Check this direction. So this is direction of the resultant force. And to indicate that this angle theta is with horizontal, draw a thin horizontal line here. Check here, you are asked to find a resultant. So in your answer, you should mention magnitude of the resultant. You should mention direction of the resultant. What is direction of the resultant force? It is rightwards upwards, 56.22 degrees with the horizontal. And third parameter, that its point of application. You should mention here that the resultant is at point Q. Now, show this resultant force in the diagram. So, the resultant is at point Q. It is rightwards upwards. So, I have shown resultant at point Q. Label resultant as a R and insert its magnitude. And show its angle with x-axis. Theta is equal to 56.22 degrees. Now listen. When you show resultant in the space diagram, are you adding a force in the system? No, not at all. It is not fifth force in the system. What I mean to say, when you show resultant in the space diagram, draw a different type of line, and that is why in the diagram I have drawn resultant with a dotted line. So let's solve a new problem. A system of forces shown in the figure. Find a single force equivalent to the given system. Find a single force equivalent to the given system means find a resultant. So how to find resultant? Rx equal to sigma fx, Ry equal to sigma fy. You get R as root Rx squared plus Ry squared. You get theta as tan inverse Ry by Rx, and write the final answer properly. So that means up to final step, what is to be done, you know, just do it. Now Rx is equal to sigma. Therefore, Rx is equal to, one by one we'll consider all forces. We are writing X component, so we should check whether the force is rightwards or leftwards. So 5 kilonewton force neither rightwards nor leftwards. So it has no X component. 10 kilonewton force is leftwards. And we are using its angle with y-axis, so X component is negative. So minus 10 sine 35. Now 20 kilonewton force. When you are writing X component, just focus on the arrowhead and check whether force has direction right side or left side. So it is left side. Don't think about whether the force is upwards or downwards, just focus on whether it is rightwards or leftwards. So this force is leftwards, so negative, and we are using its angle with x-axis. So X component is cos, so minus 20 cos 50. This force, so it's rightwards and downwards simultaneously. But remember, while writing X component, we should focus on its horizontal direction. So we say that 25 kilonewton force is rightwards. That's why positive. And we are using angle with x-axis, so X component is cos of that angle. So here it is positive 25 cos 70. So Rx is equal to minus 16.5 kilonewton. What do you mean by negative sign? X component of resultant is leftwards. Now second equation, Ry is equal to sigma Fy. Therefore Ry is equal to. Now focus on vertical direction of all forces. So plus 5 because it is upwards. 10 kilonewton force is upwards, therefore positive. And we are using angle with y-axis. So y component is cos component. 20 kilonewton force is downwards. So minus 20 sine 50. And 25 kilonewton force is again downwards. 25 sine 70. Remember, if you are using angle with x-axis, then x component is cos and y component is sine. If you are using angle with y-axis, then x component is sine and y component is cos. Check 10 kilonewton force. 10 kilonewton force, x component is sine and y component is cos. Okay, now complete the calculations and get the answer. So here Ry is minus 15.48 kilonewton. What does that mean? Ry is 15.48 kilonewton downwards. So use these two formulae and get R and theta. Remember, when you use these two formulae, don't use direction of Rx and Ry here, use only magnitude. So this is how you will get resultant 22.62 kilonewton and theta as 43.17 degrees. Now combine these two directions. Rx is leftwards, Ry is downwards, so resultant direction is leftwards downwards. And don't forget to mention the point of application. Remember, your answer must be complete: magnitude, direction and point of application. Okay, now let's show resultant in the space diagram. So resultant R is at point A. So at point A, leftwards downwards, label it and then insert its magnitude. Use different type of line, so we prefer dotted line, and insert its angle with x-axis theta as 43.17 degrees. Hope that you have understood how to find resultant of concurrent system of forces. But remember, it's not necessary that always you will be asked to find the resultant. You may face a problem in which resultant is given and components are to be found out. So in one video, it is not possible to cover variety of problems. So I am going to make many more such videos. So stay tuned and listen. If you think that you are getting benefited from these videos, then like the video. Don't forget to comment on the video. Share this video with your friends. And don't forget to subscribe